All right, so like I said, we'll do these problems. So this is the first one. I will use the formula for anything that it's very easy to use the formula for. And then if it's not easy to use the formula, I'll show you the calculator screen, and I'll actually be dragging and dropping the calculator screen in to my problem so I can see it after I'm done. So it says you're investing 5,000, and this is all dollars basically. It's just different kind of stuff. So 5,000 is the present value. So I'm going to label some stuff. I like to do this when I'm kind of organizing myself. So the present value is 5,000. It says 2.5% interest, so the rate is 2.5%. Interest compounded annually. Annually means that you get interest one time a year. Okay, so the K value is going to be 1. And it says calculate the amount of money he has after 5 years. So N equals 5. All right, so I know those things. There's basically 5 things in this formula. There's future value, present value, rate, K, which is compounding, and then N. So I have everything but future value. So my thing is, if I'm finding future value, then the formula is usually the easiest. Because once I write the numbers down, it just goes in the calculator all in one shot and I hit enter. Okay, really for almost anything else, I'm going to use the calculator's finance thing that we talked about in the notes up top. So I'll be using that on and off. I'll talk about it when the first time I use it. So anyways, for this, present value is 5,000 times 1 plus the interest rate is 2.5 over 100 times 1. The K is 1. And then this is an exponent to the 1 times 5. And I'm putting that whole thing right into the calculator. So I got to get out of here. Make sure you hit second quit. Try to not hit clear when you're doing that. 5,000, 1 plus the fraction, 2.5 over 100 times 1 to the 1 times 5. I hit enter. I'd have 5657.04. You're doing money. 5657.04. You're doing money. So round it to the 10th place. The 100th place for everything. Don't care what country's money it is. Pretty much everybody uses hundredths in terms of their money. So we're going to stick with that. It says if the interest was compounded monthly, how much would we have after 5 years? So the only thing that changes for this one is K is going to be equal to 12 instead of 1. So this is going to be 5,000 times 1 plus 2.5 over 100 times 12 to the 12 times 5. All right, so that's all that's going to change. Compounded monthly means I get interest 12 times a year instead of 1. So I can actually even go up here. I'm going to grab this. Go over here and make that 12. I'm going to go out here and make that 12 times 5. Whoops, that's 13 times 5. So 12 times 5. So I would have 5665.01. So 5665.01. So by getting interest each month, I end up with about $8 more. And that will be a very common question that you get asked is if you have these two options, which one should you pick? You should figure it out and look at it. But basically, if the interest rate's the same, but you get it compounded more times per year, that means you're going to end up with more money because the interest keeps going into the account more often and you earn interest on that interest. And that's why it matters how many times it gets compounded throughout the year.